Now the next topic is glucose. Glucose present in sweet fruits like ripe grapes and honey, etc. First of all, we will discuss about the preparation of glucose. First, from sucrose. Sucrose formula is C12H22O11. On hydrolysis, it will break down into two units, glucose and fructose. Glucose is C6H12O6 and fructose is also C6H12O6. Glucose and fructose both have same formula but different structures. Glucose having aldehyde group and fructose having ketone group. That is the main difference between glucose and fructose. Second preparation is from starch or cellulose. Formula is C6H10O5. On hydrolysis, it will give glucose. Now, I will discuss the structure of glucose. Glucose formula is C6H12O6. This is the carbon chain of 6 carbon chain. 1, 2, 3, 4, 5, 6. First carbon contain aldehyde group. Second carbon having HOH. Third carbon OHH. Fourth carbon HOH. Fifth carbon HOH. Sixth carbon CH2OH. It means in the structure of glucose, one aldehyde group is present, 4 secondary hydroxyl group are present, and 1 primary hydroxyl groups are present. Total 6 carbon are present and 12 hydrogen are present and 6 oxygen are present. So glucose shows the structure of one aldehyde, 4 secondary hydroxyl group and 1 primary hydroxyl group. How will you detect the presence of these hydroxyl groups and aldehyde groups also? So you take the example. With the help of chemical reactions. Reactions of glucose. First of all, this is the structure of glucose. Short form CHO, CHOH का 4 times, CH2OH. This is the structure of glucose. Here the glucose react with HI. It will gives the N-hexane. After heated, it form a long chain, linear chain of 6 carbon atom, that is N-hexane. It means this reaction shows that the presence of 6 carbon linked linearly. Second reaction is that HCN. When the glucose react with HCN, hydrogen cyanide, then this H positive CN negative that attacks this negative part, means nucleophile, that attack on this carbon atom, and it will form CN and OH. It means this is glucose cyanohydrine. It means these reactions show that the presence of aldehyde group in the open chain structure of glucose. Now the next reaction, third reaction. When the glucose react with hydroxylamine, then it release water molecule H2 from here and oxygen from here, H2O. Water is released and it will form CH double bond N OH. It will form CH double bond N OH only at aldehyde position, which are present at the first carbon atom. This reaction also shows the presence of aldehyde group. Next, fourth reaction. Glucose on oxidation with bromine water, which is mild oxidizing agent. On oxidation, it will change the aldehyde group into the carboxylic acid. And here it is formed gluconic acid. This reaction shows the presence of primary alcoholic group in glucose. Next, glucose react with nitric acid. On oxidation, it will form aldehyde change into carboxylic acid, and this alcohol also change into carboxylic acid, and here it will form saccharic acid. It will form saccharic acid. Because nitric acid is a strong oxidizing agent, so it oxidize aldehyde into carboxylic acid and alcohol into carboxylic acid. This reaction also shows the presence of primary alcoholic group in glucose, because this is the primary alcohol group. Next, last reaction is the glucose react with acetic anhydride. Formula is CH3COOCOCH3. Here, this acetic acid is break down into two parts, CH3COO negative or CH3COO, this sign is positive. So here it react and to form glucose pentaacetate. This part is break down and here it is join O, CO, CO, CH3, CH3. Glucose pentaacetate is formed. This reaction shows the presence of 5OH group. It means the overall structure of glucose is made up of one aldehyde, 4 secondary hydroxyl group and one primary hydroxyl group. Thank you.